Hi, my name is Zoomer, and I'll be describing and I'll be giving you a demo of our project, which is the Bracket RAG Assistant. Now, first of all, we had developed a RAG assistant for search language for Google Search, but we realized that there was no system like this for Amazon Bracket, so we converted that system to handle Amazon Bracket. And the main changes that we did was first, instead of using local LLMs, we shifted to using the these models, such as the for designer we used Amazon Nova Pro, for validator we used the Premier, and for the optimizer we used the Pro model. Uh, and now the how this project basically works is you can see we have the chat window and the agent side and the settings from the front end. The user gives the prompt. The basic goal of this project is to you can give a prompt in tech a prompt to generate a quantum computing or quantum code in Amazon Bracket, and it will generate that code. But the main issue is with using other LLMs and directly using LLMs is that you don't get the validation aspect of it and the optimization aspect of it. When you usually run the code, it just when you ask like a chat GPT or Gemini or Claude to give you the code for example the bell state, or for example the quantum teleportation, it doesn't verify that the code is correct. But how our system also verifies if the code is correct and also optimizes it, and it also explains it according to the knowledge level of the user. So that is the basic use. How it works is that it connects to the different agents, the chat window, and all the agents are connected in a loop, and the optimizer and validator are in a loop, and that when the code is uh, generated by the designer, it is checked by the validator by running it in the Bracket SDK, and if it's correct, it moves forward, but if it's incorrect, the validator corrects it, and then the optimizer tries to reduce its steps and other stuff. And basically, if it reduces something, it goes back to the validator and it checks, and it's a loop here. And then the educational agent run to just give you all the information about it. And all of this is connected to a RAG pipeline, and we have generated our own data sets. We have the and there we have three different data sets for all of our different agents: designer, validator, and optimizer. Now let's move more on to how we can use the system. So first of all, for example, let's say I want to run I don't want to run the optimizer agent. I just want to you have the validator and designer, they run always. I'm not I'm removing the optimizer pipeline from it, and I'll say that I have low educational depth, and I say create a build state or you can write anything here. I'll just use this one. Then it will just take some time, and it will use the educational LLM will be Nova 2 Lite. So it just generated the code, and you can see that it went through the pipeline, the validation, and the final validator as well. And you can see it's very basically explained, like any person without any knowledge of quantum computing can understand the Bell state circuit from this. Now, this is the code. You can easily copy the code from here as always, and it also explains the depth measure and that other stuff. So now let's just change the code a little. Let's say um, give me code for quantum. You can say the Gruber search, Gruber's search, and I'll say that I'm a very high knowledgeable person about quantum, and I also want the optimizer agent to run. So I'll give it a did. We can also have multiple files, and you can like do that as well. That also works. So let me give the prompt again. I'll just give it in the new tab, and let's see how it works. It will take some time if you also choose the optimizer agent. It will also add like around a few extra seconds for if you choose an higher educational depth. to generate it, and you will see how much it changes according to that. So yeah, okay, it generated it in the previous one as well. We'll just check from here. You can see now, you can see that it explained that in very simple term, but this is in very, very deep, and like a normal person cannot understand what this is explaining. So this is the highest educational depth that we cover. It explains everything in very deep detail, as you can see. And this is the code for 3 qubits of Grover search, and you can see it shows all the details here, and validation pass, so the code runs as well. It also shows you that, and you can copy the code and you can run it on your quantum simulator or the quantum computer, and uh, this can work. So the basic goal of this project was to add this part to the already existing Amazon Bracket simulator, because that simulator does not have the capability to actually generate the code and validate the code as well. So if we add this part to the already built simulator, then you can actually just have an agent view on the side that just generates the code and runs the code for you as well, which will save a lot of time for quantum scientists as well. So this was basically our project, and uh, thanks for listening.